Okay, so what I plan to do is I've actually got two screens here so I can see if there's any hands up. The talk is divided into sections really, so I can pause a little bit to see if there's any points raised so far. But failing that, then we can wait to the end and talk about anything of interest. Other than no hands going up, I'm just going to plow on and assume all is well. So, Web 1. So this is the invention of Tim Berners-Lee working at CERN in the early 90s. And he really built on previous technologies running on the internet. Now, I'm sure this group already knows about this already, but I will recap how Web 1 works. So with Web 1, you have a browser on your desktop. The first sort of commonly used graphical browser was Mosaic. I certainly remember compiling that from source. And of course, we have various servers located on the far side of the internet. And in this simple case, in this example, we've got a web server. Now let me put on my laser pointer, located at cars.com. That's its address. And, going back to the early 90s, the technology hosting that server would be the original CERN web server. Now, this web server is very simple. All it really does is fetch files from the file system and serves it back to the client. Now, if the user types in a URL into the web browser, http://cars.com/peep.xml, that is actually broken down into a scheme, which is HTTP, a server address or authority, as it's called, which is cars.com, and then the path, which is peep.html. Now, the HTTP is telling the web client, the browser on your desktop, to use the HTTP protocol to talk from your desktop to the server. So what actually happens is your web browser connects to the server, uses the HTTP protocol, it issues a GET request to fetch the page that you've requested. The web server then reads that file from the file system and passes it back to your web browser. And then your web browser, Mosaic in this case, will start displaying it. Now, this file format is HTML, hypertext markup language, and consists of sort of plain text with markups, giving hints really to the browser of how to display it. So in this case, we're saying we've got the text Pete's car, which is heading 1, so nice big and bold at the top. And we've got a further link in here, which is an image. And we've got a reference here, which is an image. And that's telling the browser that you need to get that image in a second request to the server. So the browser would do a get of that image, exactly the same process. We'll get the image back, and eventually we'll see on a browser the results of the HTML rendered with the image inside it. So very simple, very standard, and this goes back to the early 90s of Tim Berners-Lee's original invention. Now, if we put some more labels on that, the protocol between the desktop and the server, HTTP, Hypertext Transfer Protocol, is captured in standards. HTML, Hypertext Markup Language, the format of the text is also captured in standards. So very simple, very straightforward. I'm looking for hands so far. I can't see any, so I'm going to plow on and talk about Web 2. Now, Web 2 really represents roughly where we are today with the vast majority of web pages. So we've moved forward a bit in time. We've got a Netscape browser, a much more sophisticated browser, actually written by the originators of Mosaic. And we also have a much more sophisticated stack on the server side. So we see now we've migrated from the CERN web server to Apache. Apache is by far the most common web server around. And actually, just point of interest, Apache came from contributors who are gathering together all the various software patches on the CERN server, and it became a patched CERN server, and eventually became Apache. Anyway, so Apache is interesting because it allows code to run on the web server, mostly in the form of servlets. There are other mechanisms available, and that servlet will typically talk to a database. So we've got now a much more sophisticated web server. It's got code in it. It can generate pages on the fly. It's talking to database. It's no longer a simple file system-based server. Also, the Netscape browser is also much more sophisticated. It can now use cookies. Cookies, we'll see how that works in a minute. Cookies is a way to link individual HTTP requests and responses together into a group of sessions. Netscape can also actually run code directly in the browser where previous generations web browsers couldn't. And that's usually in the form of JavaScript these days, and that JavaScript will be downloaded and code will be run inside your browser. So let's see how that works in this world of Web 2. So like before, our web browser would get the main page, but this time the web server is probably going to generate this HTML on the fly. It's got code, no need to store it. It will generate on the fly. And you'll see one thing here, the server is replying with, as well as the response is actually setting a cookie. Now the server is just making up a value for this. And the protocol with cookies is that once the server has set a cookie, all future requests and responses maintain that cookie. And in fact, your browser is going to store that cookie set by the server. Future requests, as we saw before, the client then sends that cookie back again to the web server. We're probably going to generate the picture this time. We've still got that cookie in there. Now, we saw, if I go back again, that HTML page has got the link that we've talked about, but also has got a link to some code, this JavaScript code. So we're going to download the picture. We're also going to download that JavaScript code, and the browser is going to execute that in its environment. So now we're executing code both on the client and on the server. Now this, this is a completely made up example, but let's say that JavaScript program is going to try and find out how much charge my car has got. Now, the other thing these fancy new web servers can do, they can host arbitrary APIs. Browsers can actually call on them to find out more information based on the user's requests. So in this case, this charge.javascript program is going to execute. It's going to try and find out the charge status from the server using an API call. The server is going to somehow find out what that is. It's going to reply, and our net result is we've now got an enhanced web page. It includes a title, a picture, and it's got some active elements in there, which is come directly from the server. Now I can see a physical hand up.
Yes, API, application program interface.
Quite right. Thank you for putting that out. I'm just going to finish off, and then I'm just going to pause a little bit, see if there's any questions on this. Now, because all these requests response have the same cookie, they're deemed to be part of a single session, whereas in the Web 1 world, each request response was completely isolated from each other. That's one thing to bear in mind. The purpose of really cookies is to bundle together requests and response into one go. Okay, so we can see big main changes here is we're running code now on a desktop. we've got code on the server, and we've got this database here. Now, this database here can be used to obviously serve your content, in this case, generating pages on the fly view, but it can also be used to store information about you. So very frequently, websites will store the fact that you've done all these requests. That will go in the database. Okay. Now, one thing you'll notice now is that this data is now outside of your control. Whereas Web 1, there was no data. You could see everything that's going on. Now with Web 2, you've got code running here, which you've got no idea is doing. And you've got data stored in here, which you've got no access to. Okay, so I'm not seeing any hands up. So key features of Web 2. So the web server style of Web 2 is now executing code to generate dynamic pages on the fly. And if you think about that for a minute, that means that two people using the same server might see the same page in a different way, because the server is generating it dynamically based on yours. I mean, a good example of this, perhaps, if your browser is configured, if you've got poor eyesight, that the web server might be generating a high contrast version of the page, whereas, on your phone, maybe it's using different fonts or whatever. Now, the web server can now store personal data on Web 2. And more interestingly, for the purpose of this talk, anyway, is the web server can now, from these requests and responses, actually get quite a bit of information about you and store it around. It will know, obviously, what your browser versions are, what your IP address is, IP, Internet Protocol, and from that, probably where you're based, your physical location. It can also use techniques called fingerprinting, where it'll get lots of individual pieces of data about you, maybe your time zone, your screen resolution, so on and so forth. And actually, without you even logging into the web server, it will pretty much be able to identify you as an individual, and so can track your usage day to day as you log into the site from day to day. You've got the same fingerprint. It's likely to be the same person using the web server, and so on and so forth. And of course, web server will set cookies to combine requests and responses into a single session, which very often is a very good thing. The first request might be a login to a web server, and subsequent requests might be, using that web server. You might be querying your bank account or whatever it might be. But one thing that is often missed in this, that these sessions can cross web servers. And this is known as trackers. So, I'll mention the big name for the first time now, Facebook. Now, Facebook is obviously a social media platform and will use cookies, but it will also insert its own cookies into other web servers. So, for example, you might be using Amazon, you might buy something. The fact that you've interacted with Amazon will use Facebook cookies, and those cookies will be stored at Facebook. And then Facebook, when you come to use Facebook directly, it will say, right, you've been using cookies on Amazon, therefore I'll serve adverts related to your recent purchase on Amazon. So these are known trackers where you go to web servers, two different web servers, and some web servers can track your visits across them. And of course, you've got much more sophisticated browser now. It can execute code, it can run requests to the server, and can store cookies. Okay, so, Neil, I can see your hand up.
Yeah, it's you refer to database, but presumably, since in a lot of instances, what we're dealing with is information sourced from databases all over the place. I'm not quite sure how this actually links in practice. So you've got the web server doing things, but where you've got multiple sources of input, how's it actually working?
Okay, so don't think as a database as, rows and columns, like a table type database. Facebook, for example, uses a object-oriented database where it has relationships between pieces of information. So over time, Facebook will figure out actually quite a bit about you just by interacting with the Facebook server and other servers. It will collect various pieces of information. It will identify you as an individual. It will work out your wages, your sexuality. It will have relationships to the people, your wife or husband, your siblings. It will know your buying habits and so on. And these databases are often in the form of a graph DB. So it's more a relationship database. It will create and try and get a profile of you. It may not be 100% accurate, but what Facebook and others are trying to do is to give you targeted adverts. So if you've, bought a lot of, garden equipment, then it's going to work that out that you bought lots of garden equipment from Amazon. You come to Facebook, that will be in your profile, and it will start choosing adverts to send to you related to gardening. Did that sort of...
Well, from the standpoint of profiling situation, but let's say I'm looking up something that I haven't generally or haven't ever, for instance, needed to look up before. Say some new illness that I've never been associated with, or something else like that. Therefore, I'm going to try and find something from a database that is somewhere remote from me, which I've not used before, and so on. Is it, so if you're talking about things being stored in relational databases and so on, I mean, my idea of relational databases is sort of 20 years old, so it probably is that everything is run in an entirely different way now. But in terms of the ways in which this is finding something in a database, if it's using its own information about where that has been found before, presumably, that's stored in its own server, and then actually looking for routes to access that for this specific instance, to transfer across to me.
Yeah, I'm not sure if I kind of get the question, but these web servers will typically have really two types of data. So let's say, let's forget about Facebook for a moment. Let's say the server you're trying to contact you is your bank. It's going to have a relational database with your bank accounts, your balance, your transactions, and so on. And the application running in the servlet on the server is going to be listening to your requests. It's going to be saying, okay, you want to look at your balance, or do a query on the database, find your balance, and send it back to your browser. And your browser will use JavaScript on the desktop to nicely format it in a nice, pretty way. So that's one use of the Web2 style of applications. But also, of course, the Web2 applications is gathering data as you do these queries. And a lot of social media applications want to gather as much data about you as possible, and primarily for the purpose of serving you targeted ads.
Yeah, sorry, I'm not sure that's really my thing that I'm less certain about is what is happening when it is something that is where it's not previously, where the server is not previously experienced with you relating to it at all.
Yeah. So servers may not know you by name.
Yeah.
They may not know, any kind of ID about you, but it'll make up an ID. it will know your browser fingerprint. So if you access the same web server from day to day, you've not logged in or given any information, but the web server from your browser fingerprint, we're pretty certain it's still you. You know, it'll be able to correlate your 2 requests to the web server over several days to be the same person. So if on day 1 you've accessed, you know, some gardening equipment, day 2 you've done something else, you know, the social media platforms will be able to link those together, even though you haven't logged in or given any kind of indication who you are. It still knows that it's the same person. You'll just be a you know, randomly generated number. And that's all it needs to know to give you targeted ads.
Right. Okay.
Peter,
Yeah.
Question, if I may.
Yeah.
I've set my web browser to delete cookies on exit,
Yep.
thinking that I'm retaining some privacy. But in practice, I still find that Facebook comes up with some, well, very few, but it does come up with adverts that have related to my previous activity.
Yep.
And I'm wondering if perhaps it's finding out that through this fingerprinting. So
yes, yeah, it could well do. So the fingerprinting is not cookies. It could be all these little bits of information about your browser, you know, as I say. Like,
yeah. So is it futile to you know, delete cookies?
I'll come on a
pointless
little
exercise?
bit. Yeah, I'll come on a little bit later, if I may, about ways to use Web2 in good ways. And in fact, that's in a couple of slides' time. But
Okay.
there are tools on the internet to actually test your browser configuration. So
Yeah,
one thing you can do is you can either configure your browser to use a random fingerprint on every single request, which defeats the servers being able to track the same fingerprint across different request responses. Or you can take the other approach and set your browser up to generate a very common fingerprint, in which case that will also defeat the servers because they won't be able to distinguish you as a person from all the other people in the world with the same desktop fingerprint.
Okay, right. Thanks, Peter.
Okay, so we've already sort of touched on this. So what's the big problem? So we now got data about you stored on a server which you've got no visibility on it at all, and it's running code. And we see really time and time again in the press all these big fines of, you know, the social media sites come up a lot, right? So here's an example about a 5 billion fine for Facebook about not securing people's personal data. And it comes up again. There was a big leak of internal papers from Facebook, which describes the horrendous confusion that exists inside Facebook, all sorts of things they're doing. If you've got personal data on this database not under your control, perhaps that server isn't looking after it very well. They've been hacked. Your data can actually then end up to be useful information for hackers. Good information on Wikipedia actually about privacy concerns with Facebook, definitely worth a read. I'll just finish this page. I can see a hand up. Here's an interesting one actually. So if we take for a moment that your data on a social media site may not be as secure as you'd hope, they might get hacked, you may not have all the privacy settings down. Let's say you use your bank, and when you log into a bank, it always asks you for secondary questions, you know, your wife's maiden name, the name of your first pet, and so on and so forth. And guess what you post on Facebook? You say, right, here's a picture of my first cat. and suddenly you've shared on social media information that hackers love to have to try and guess access to your banking system. So it's not only privacy, it's giving clues away to hackers. And if those clues to hackers that you've volunteered is not secure and not shared appropriately, then your financial accounts can be at risk. Another big one specific to the UK here, which actually really personally got my attention, and this is Cambridge Analytica, which is was a UK company. And what they do is sell their services to send very specific targeted political adverts. So, for example, again, thinking of Facebook, who's got this set of profiles about you and who you've got relationships and, what your political affiliations is, what your wages are. Let's take an example, just make someone go, okay, my sister is a big Facebook user. She's a care worker. All right, she's married and her husband is retired, used to work on the railway lines. Now, Facebook will know all these facts, and Cambridge Analytica would set it up so they would target not her husband, but my sister with very specific political adverts based on that profile that will say things like, if you vote Labour, then there'll be 10,000 jobs lost in the railway industry. So that's what Cambridge Analytica's job was, to create very targeted political adverts. And it was used in many countries worldwide. It was used particularly in the Trump campaigns and, of course, the Brexit campaign. And to me personally, I just think that's wrong. You need to make up your own political minds, not have all these personal ads targeted for you. And by the way, Cambridge Analytica got a dump directly from Facebook to help them support that. Facebook is another revelation that came up in some court cases. They don't know where their data is kept. The impressions that we're getting is that Facebook as a company is very chaotic. Very short time, people work there. New guys don't really understand what's going on. Worth a mention on this documentary called The Social Dilemma. Definitely well worth watching. It's a documentary that features many of the early software developers from Twitter and Facebook and so on, and explains how these social media platforms actually work and what their motivations are. And oh yeah, here's a good one. So there was a question about if you turn off cookies, can they still track you? This is in the references at the end, but there's some tools on the internet that can actually test your browser to see if you are trackable. It's called Cover Your Tracks, and highly recommended that you go in there. And by the way, Chrome by default has very poor blocking for blocking tracking. Firefox is pretty good default out of the box, as it were. Now, in some cases, and I'll give an example of WhatsApp. Now, WhatsApp is a peer-to-peer chat talk, and they tell you it's end-to-end encrypted, so that no one, including WhatsApp is owned by Facebook, no one can actually interpret what you're saying to each other, and that does appear to be true. But there's big points here that even though your data is secure, your metadata may not be. And there's some good examples where just knowing who you talked about and when is enough information to give away what's going on. There's some examples here. I'll let you read them yourself later. So any questions? Sorry, Neil, yeah.
I was going to ask about virtual private networks and what, how they link into this, and whether they're at what levels they're effective and so on.
Yeah, so VPNs will give you a let's say artificial IP address, so that the servers will believe you're from a different physical location. So that will defeat a few of the techniques that these servers will use to find out who you are. Your fingerprints will still apply, your cookies will still apply. So it's a little bit of privacy, but not a huge amount. The data going across the internet will be encrypted anyway, so VPNs are not going to increase your encryption. It's just going to fool the server about knowing where you're physically located. I've got another hand up.
Is the incognito mode effective at all in blocking any of the personal information when you're browsing?
No. So the secret modes on your web browser, all that's really doing is stopping your browsing going into your local history. If you go back to the diagrams where I'm showing the web browser talking to the server, all that still applies if you're in those secret modes, and the server's receiving the requests in exactly the same way.
Okay, thank you.
Okay, another way to look at what's going on is look at the GDPR fines. This is the European laws, and you can look at these yourselves. But one thing that struck me, these are the top fines so far. Meta, Facebook, and WhatsApp is by far the most common company that appears in this list. So these are fines that the companies have done something bad related to privacy. The EU has fined them accordingly. Now, sometimes companies make mistakes. They incorrectly secure data on the internet, that gets hacked, and the EU fines them for that event. But when you see companies all getting fined pretty much, well, several times a year, you think, well, this is more a cost of doing business rather than a real deterrent from breaching people's privacy. So what can we do about this? And I promise I'll get to Web3 shortly. I'm definitely getting there, honest. Now, what a vast majority of people do about these problems is to use these web services and ignore any issues. And to be honest, the chance of you being hacked from leaking data, is statistically very low. Even if you give away a whole bunch of data about your first pet's name in public social media sites, the chance of a hacker making use of that is low. Even if your data on the server is leaked to track, the chance of that causing a real issue is relatively low. Vast majority of people are just not aware of any privacy issues and just carry on using any old website. Now, another approach you can take is really the opposite and avoid using these websites that store personal information. So that means reading their privacy policy, understanding how they work, what sort of data they collect about you, and then making a judgment call. Do you want to make use of that service? Are you happy for them to hold on to that data or not? Another way to avoid these is to migrate to more trusted applications. And we see this happening quite frequently now, and every so often it makes the news. So instead of using Twitter, you use Mastodon. Instead of using Facebook, you use Discord. Instead of using WhatsApp, you use Signal. All these substitutions are broadly the same sort of applications, but have a much more tighter privacy policy around them. And, for myself, myself and our family, we have moved to Signal instead of using WhatsApp, for example. Another way is to use these websites that you no longer trust, but be careful when using them. So be careful with your security assessment, read the privacy policies, minimally share personal details, so lie about your pet names or any kind of details that's related to secondary passwords on your bank account. Block trackers. So use a decent browser that blocks trackers between these cookies that survive between websites. Test your browser configuration to make sure trackers really are blocked. Use tools like AdGuard, which as well as blocking ads will block these trackers. Or, and finally we get there, Web3, yay. So I'll pause a minute for any questions before we delve into what Web3 is all about. Any hands up so far? Okay, I'm not seeing anything. So let's talk about Web3, which was the whole point of this talk after all. So now we've got a more modern browser, Chromium, and for Web3 applications, the web server has gone back to the Web 1, and it's very, very simple. All it is the file server for HTML pages and JavaScript files. Now, instead, with Web 2, our personal data was held on the server. With Web 3, what we're doing now is taking your personal data and storing it locally. So it's under your personal control. It's your data, not someone else's data. So your details about, perhaps your social media interactions, your use of banking systems and so on is now under your personal control rather than part of the web server. Now, the way Web3 works is we download HTML pages from this very simple web server, as we've done before. We download JavaScript, as we did for Web 2. The JavaScript program is run in the browser, but from now on, there's no further interactions with this web server. Actually fetching any kind of balances or running an application is now done talking to your local database. Now, this is a key difference between Web 2 and Web 3. So typically, your browser will talk to this local database. It'll unlock it in some way, with a secure key. And it will call, let's say your application is trying to get your account balance of something. It will call your local database to find that balance rather than talking to the server. And the web application will be running, it will display all the information without talking to a server. Now, you might be asking, well, what sort of thing can this local database be? Well, it can be one of several things, but mostly this day it's talking to the blockchain. Now, blockchain, I'll mention this for the first time, is a decentralized database. That's the way to think about it. It's a vastly distributed database around hundreds of thousands of servers around the world with no single point of ownership. So in order to access that blockchain, you'll use a piece of software called a wallet, and that gives you your link from your desktop to your blockchain. So your desktop, your browser will be talking to your wallet, and your wallet will be talking to the blockchain to get any information about you which you've previously stored on that's related to your application. Okay. So any questions now about this? This is a fundamental concept of Web3, taking back control of that data so it's now under your control.
Yes, I have a question. The wallet presumably is under control of applications like, for example, a bank. My NatWest Bank, for example, would have its own local database. Is that correct?
Yeah, so if you're using a bank, you will be using a Web 2 style application where your browser would talk to the bank, which will be a centralized application. It will talk to a database, it will get your balance, you can do transfers and so on. So banks will not typically need to use Web3, but the big thing, there's a big difference here between banks and social media platforms. Banks are regulated by financial authorities around the world. And if a bank does anything stupid like get hacked, then the banking authorities will jump in and do something about it. So you probably make a judgment call to use your traditional bank in a Web 2 style, in a centralized way. You may make the judgment call not to trust social media sites in the same sort of way as you would trust your bank. So a lot of these things is judgment calls. How much do you personally trust the server that you're talking to? Personally, I'm a big belief in understanding how the server works, what their motivations are, read something about them before using them, so you can sort of like sensibly make that judgment call. Go on.
Yeah, Pete, I'm not very familiar with blockchain, but my basic understanding is since it's working on a massive basis, then presumably it's a high energy user because it's got to communicate on a mass scale, or is that totally wrong? Is that
I've got some slides a bit more on the blockchain.
Oh, okay.
Move on.
Yeah.
But if I don't bring it up, remind me about the power consumption, because that is an interesting fact. We see that in the press quite often.
Yeah. Okay. Thanks.
Yeah.
And Peter, you haven't mentioned cookies at all. Are they don't feature in Web3?
No, not at all.
No,
not relevant. Cookies are there to control or to create a session of several different request responses between the desktop, browser, and a server. And here we're talking to a wallet, so cookies just not relevant.
Yeah. Is JavaScript absolutely essential? I have an idea my browser stopped supporting JavaScript 2 or 3 years ago.
What you're probably thinking about is Java. So there's two completely separate programming languages here that have run in the browser.
Okay.
In years gone by, Java itself was run in the browser. Yeah, that's pretty much gone now. But all browsers support JavaScript. I know they use the same name, but they're actually quite separate technologies.
Okay. Okay, thanks.
Right, so as Neil was asking, let's talk a little bit about blockchain. Now, I didn't really want to go too much into blockchain because I feel that's like a separate talk, really. Very interesting technologies, but just to support this Web3 talk, I thought it'd be useful just to talk a little bit about it. So blockchain is a largely very big distributed database, or decentralized, they tend to use the term. And the way you get access to a blockchain is always via a wallet. So a wallet is something that you use on your desktop, on your phone, and that grants you access to the blockchain. Now, a way to see the blockchain is, now I'm not going to use the proper terms here, but a series of accounts. You will have an account that belongs to you, and you can visualize that account as maybe a transparent box with a hole at the top and with a key to unlock it. So that means that what's inside your account is very visible. Anyone can have a look to see what's inside it. Anyone can use a slot in the top to insert some assets into your box. But to take assets out, you need to unlock it. And before you're thinking that anyone can read what assets belong to me, there is nothing in the account that correlates an account on the blockchain with you personally. The way you get access to that account is you using a quite complicated private public key combinations, and you need to provide that information to your wallet so it can unlock your account. Okay, so of course there's lots of other accounts on the blockchain. If you're running a Web3 application on your browser, there's probably an account that's assigned to that application, an application account, let's say. And there may be other accounts that belong to other people in the blockchain. Now, one thing that most blockchains support is this thing called smart contracts. Now, this is code on the blockchain. So let's say your application, it's a financial application, and you want to transfer some assets from your account to some other account. The way these applications would typically work is the wallet would first of all unlock your account. It would then invoke a code on this smart contract, let's call it transfer from my account to some other account and how much assets to transfer. And then that smart contract will actually execute on the blockchain in a transactional way. So it will draw some money, you've unlocked it. So the smart contract now has access to your assets. It will draw and it will deposit that same amount in some other account. So instead of having code with Web2, which is hidden away on the web server, Web3 has smart contracts running on a blockchain to do similar tasks, executing your application code, but in a much more visible way. You can actually view this smart contract. You can view its source code. You can see what it's doing. Hopefully that kind of explained enough about the blockchain. So just to answer Neil's question from earlier, there are different types of blockchain. So for example, Bitcoin, one of the most popular, or the most popular cryptocurrency, has a blockchain called Bitcoin. The second most common is called Ethereum, which is a different blockchain. And these two blockchains have different features. For example, Bitcoin doesn't support smart contracts, so it's no good really for Web3 applications. The Ethereum blockchain does support smart contracts, so it's quite often used for Web3 applications. Now, these different blockchains, one thing they need to do in a very distributed way is to confirm transactions. So if you're doing this example where you're doing transfers, you want that transfer to happen exactly once. You don't want the withdrawal to happen and not the deposit, or the deposit and not the withdrawal. That would be, transactionally a failure. And the way the blockchain maintains transactions is a thing called confirmations. Now, these confirmations, you can imagine it as, or maybe a tree falling down in a forest. And you'll ask your question, did that tree fall down? Well, no one saw it, so maybe it did, maybe it didn't. So you send someone in to watch that tree. The tree falls down, that someone comes back, reports to you, yes, that tree did fall down. And then you think, well, can I trust that one person's view of that tree falling down? Okay, perhaps not. You send two people to confirm that. They both come back, that tree fell down. Well, okay, now you're pretty certain that event did happen. And maybe after 8 or 9 confirmations, you utterly believe that tree did fall down. So blockchains work on the idea of confirmations. And these confirmations do take up, do require some work. Now, the way the Bitcoin blockchain does confirmations to prove that work's been done is via an algorithm called proof of work, which is solving some very complicated equations which use a lot of CPU power. Hence all you see in the press that, cryptocurrency is terrible because Bitcoin consumes the same power as a small country. sort of headlines you see. But that's not the only way to perform these confirmations. There's other algorithms to choose. Now, Ethereum, for example, uses proof of stake, a different algorithm to underpin these confirmations, and they use very little CPU power. So these days, there's only a few blockchains that uses proof of work. Now, if you're going to, if you're environmentally sensitive and you want to play around with blockchains, you can quite easily avoid the blockchains that use proof of work. Hopefully that sort of gets some way to answering your question, Neil. As I say, I didn't really want to go into blockchain because that's a, you know.
No, thanks. Yeah, that's fine.
a whole new. So some features about Web3 then, just to summarize, and I'll pause after this to see if there's any kind of further questions. Whole point about Web3 is to move this data under local control. Most Web3 applications use a blockchain implementation, although they don't have to. So I don't want to give the impression that blockchain is the only way to do it. There are alternatives. So applications move from to a smart contract. We use blockchain as a sort of decentralized ledger, if you like, to manage your transactions. There's no single entity you need to trust because your data is distributed across hundreds of thousands of servers. There's no single server you need to trust, unlike the Web2 model. Your private key unlocks your wallet, and that enables your Web3 application running in your browser to get access to the blockchain, which gives you access to the data that your application needs to run. And wallets can contain things like balancing, voting tokens. There's a thing called non-fungible tokens, which I'll mention now since I've mentioned it. So if you imagine I've got £1, if I've got a £5 note and you've got a £5 note, we can swap it. It makes no difference if we swap the individual notes, we've both still got £5 left. So £5 notes are called fungible. You can swap them, it makes no difference. Other sort of tokens may be the lease to your house. I've got a lease to my house, you've got a lease to your house. We can swap them, sure, but they're not equivalent. You know, that my house is not the same as your house, and those are known as non-fungible tokens. So your wallet can contain fungible tokens like coins and things that represent currency and other tokens that don't represent currency. And it contains non-fungible tokens, maybe things like rights to vote in a group of some way, or one example I saw was using non-fungible tokens to track carbon balances between countries. So, so wallets can contain multiple different types of assets. Now, there's also a secondary implementation, which I'm not going to talk about, other to say that it exists. This is an implementation called Solid, and it is championed by the Web1, the World Wide Web inventor, Tim Berners-Lee. So it has a lot of weight associated with it because of him, but it's just not that popular. But I did come across, BBC was doing a trial with the Solid implementation of Web3, and that was about storing what you've watched in BBC iPlayer, so you can store that and look after your watch list yourself. I don't think they ever, made that public, but they were trialing Web3 with Solid. So, any questions before I jump to a quick demo so you can see what a Web3 application typically looks like? Any hands up? I'm suspecting this is a bit too much. Okay, I'll push on my little demo. Hopefully you can see my whole browser window now. Maybe we can zoom in a little bit. So this is a website called PancakeSwap. Okay, and this is a Web3 application. And what it does, it provides really the equivalent of a bureau de change for decentralized finance applications. So if you've got some Web3, you know, maybe some coins, some Bitcoins, and you want to transfer them to some other coins, you can swap them on sites like PancakeSwap. So bureau de change is a pretty good way to look at it. So there's no centralized server here. All I've done is I've gone to this website, I've downloaded the HTML, I've downloaded the JavaScript, and it's all running locally. Now, before I go into the demo, you can use PancakeSwap to swap tokens, but another use is you can actually earn money or earn tokens from these sorts of sites. Now, the way this works is in order for PancakeSwap to do this swapping of coins, it needs a pool of coins, a liquidity pool, in order for that to work. And so what you can do as a user is you can lend your coins to PancakeSwap. They will put that in a liquidity pool, and then any transactions that your coins are used in, you'll get a small cutback of that transaction. So if someone uses your coins, they do a swap, you get a small cut of it. So it's a kind of simple way you can just sit back and earn a little bit of coin in return of lending your money to the site. So what else we've got here? You can hopefully see in my browser, I've got my wallet. There he is, MetaMask. So this is my wallet. It does this nice little thing here, which I've got to show you. Follows the mouse around. Now I can unlock my wallet with my secret, which I'm not going to remember. Always happens in demo. Oh, let me cut and paste this. I'm sure I got that right. Ah, there we go. Can't type. So this is my unlocked wallet now, and you can see the assets that's in my wallet. I've got some BNB coins that's worth £322. I've got some other balances. So these are fungible tokens. This is where I keep my non-fungible tokens. And I've got some activities. So this has connected to the blockchain, and it's looking inside my little plastic box and showing me what assets I've got. And now I'm using this wallet to get access to my assets on the blockchain. So far, though, this Web3 application doesn't have access to my wallet. So I can hit this Connect Wallet button here. And it does support many different types of wallets. I'm going to choose MetaMask, as you can see. And now I've connected my Web3 application running in a browser with my wallet. And you can see straight away that we've got this hex sign here, which is showing that it's connected. The Web3 application started to work. It shows it's connected. It's showing that I've got some money which is available to collect from my earnings on this website. Hopefully that's clear. So just to recap, I've started up PancakeSwap. I've downloaded HTML. I've downloaded JavaScript. The Web3 application is connected to the wallet. The wallet's connected to the blockchain. I've got access to my assets, and now I can interact with my wallet. So I've got the equivalent of $6.30, and I can harvest it. And this represents a very typical interaction that you have with any kind of Web3 application. You connect your wallet and then it works and you can click on buttons and so on. So in this case, I've tried to harvest it, and the Web3 application is talking to my wallet my wallet saying, whoa, you need to confirm that this Web3 application is going to allow you to do this. So I'm going to click confirm, and we'll see that transaction is submitted to the wallet. It's gone onto the blockchain already. That's going to carry on going. The harvesting will carry on, and we'll gradually see this money disappear down. So now the money is actually being moved from the account belonging to the application to my personal account. So I've withdrawn the money onto my blockchain, onto my wallet. And this represents, I know this is a financial application, but this represents very typically how you interact with Web3 applications. So pause for questions so far before I move on.
I have a very simple question. Is this real money? I mean,
okay, good question. So, Web3 with a blockchain implementation does use crypto coins to power it, if you like. And if you haven't got any crypto coins, you need to buy some. Okay, so you'll go to an exchange like Coinbase, and these exchanges are regulated by banking authorities. So with Coinbase, you log into Coinbase, you transfer some pounds from your bank into Coinbase, you click on the buttons in Coinbase and then buy the coins you want in substitute for pounds. So now in your wallet, you've got some coins and you obviously got less pounds. So yes, a lot of these coins actually mean money. They have a trading value, the same as any kind of exchange, like the stock market. How much each coin is worth goes up and down over time. As the same as, dollars versus pounds goes up and down. And if you want to sell back these coins, you can go to Coinbase and you can sell your coins and send the money back to your bank account. So yes, these represent real money, and the value goes up and down. And just to give you a feel of this marketplace, I just saw this morning that in total, there's about $1 trillion in crypto assets around the world. So this isn't a small thing, this is quite major financial applications going on here. Tom.
Excellent presentation, by the way. Absolutely.
I'm not finished yet. Hey, I'm still going.
No, but it's a lot of new things, and I'm very enthusiastic about what I'm hearing. But let me just recoup what I think I'm understanding and correct me. And if it's too much to correct, I'll go back and watch it again when I get the video from Tom. But when you go from Web 2 to Web 3, basically what you're enabling is a protection of all your private data, and that is done by virtue of Web3 relying on blockchain.
Yep.
And you have shown us the financial particular application, but the same type of process goes on with other types of applications where you're not involving finance. Is that correct?
That is exactly right, yes. And the next slide, I've got some other examples of Web3 applications not in finance.
Wonderful. Thank you.
Okay. Okay, so let's jump back to the slides. All right, so that was the demo over with. So and we're beginning to wrap up now, so you can wake up now. Now, I'm not going to go these in details, but I don't want to give the impression that Web3 applications are only financial. Okay, there's a number of social networks that are Web3 style applications. So the data is on the blockchain instead of on a server. And these are, broadly Facebook alternatives, if you like. One interesting, what I personally find interesting, is file sharing applications, you know, so equivalent of Google Drive or Dropbox. And so these are a way to store your files securely, but in a blockchain way, instead of relying on Google or Dropbox to avoid, you know, anyone else looking at your files. There's equivalent of messaging apps, you know, WhatsApp sort of alternatives. There's the Web3 equivalent of video streaming, or YouTube equivalents. Now, it's fair to say that at the moment, these applications have nowhere near the take-up as traditional Web2 applications. They're currently tiny, but they do exist. They do have, you know, hundreds of thousands of users around the world using these applications because they've chose not to trust centralized applications. There's a number of decentralized exchanges. We've already looked at PancakeSwap. There's loads of others. There's many decentralized finance applications, which are broadly banking alternatives. You can do borrowing, lending, currencies. There's this concept of stable coins, where instead of the value of coins such as Bitcoin or Ethereum goes up and down each day against the dollar, these stable coins have got a fixed peg against the dollar. So you can use those as regular currencies, if you like, because you know they're not going to be affected by currency fluctuations. One interesting use of Web3 applications is what's called decentralized autonomous organizations. So these are groups who are getting together for some particular purpose. I've just got lightning out the window, by the way, if you hear anything. And it could be for anything, but they might be using Web3 applications, things like voting or just organizing the members of the groups. Non-fungible tokens I've already mentioned, and I've already mentioned that non-fungible tokens are getting used or at least getting interest in by governments and big institutions. So I don't want to give the impression that this is like the blockchain or Web3 is like fringe for these kind of secret cryptocurrency ideas. It has much wider implications than just, you know, the equivalent of currencies. So, well, we're definitely really near the end. So let's have a look at what may happen in the future. Our crystal ball, if you like. So Web3 is already strong in decentralized finance. So this is, you know, Bitcoin and Ethereum, also strong in gaming. So you might be using a game and you want to buy extra, you know, shields or swords or whatever that game might be doing. And that might be a Web3 application that allows you to interact with that gaming. And the metaverse, this idea is you can interact with, you know, do your shopping in, you know, 3-dimensionals on, or, you know, virtual reality with your headsets on. Web3 is already strong in these areas. But if you were going to create a traditional bureau de change, to say swap dollars to euros, you'd have to go through banking rules and paperwork, and it might take several years for you to get a bureau de change off the ground because of all the paperwork you have to fill in. In this decentralized finance world, you can do that in an afternoon. You know, in your bedroom, you can set up a bureau de change, go live, no regulation whatsoever. So whilst you might be doing something really good with Web3, it's also a real easy thing for scammers to put Web3 applications up on the internet with no kind of structure behind it at all. All they're interested in doing is taking your coins and then disappearing a month later. So at the moment in finance, in Web3, There's some areas which are really well trusted and have been around for a long time, but you do get this Wild West aspect as well. Bear in mind, all right, so if you're using a traditional bank, a centralized bank, and you lose access, you can call up a call center. And you know, you can give away your you know, your parents' your mother's maiden name and your name of your first pet, whatever, and convince them you are who you say you are and get access to your account again. If you lose the key to your wallet in Web3, that's it. There is no call center. You've lost. Whatever assets you got on the blockchain, you and no one else have got access to them. They are effectively lost. So again, in Crystal Ball, what do we think Web3 will impact social media? So I've mentioned Facebook a lot. That's partly because I did some investigations for U3A a while back about how trusted Facebook is with respect to U3A. So we're wondering how Web3 will impact social media. It may well be that social media sites will just completely ignore Web3. They'll carry on their merry way using centralized data. That may be. There could also be a big adoption. So it might be that you'll start to see social media sites saying, yes, we're fully Web3 now, you can completely trust us, all your data's on the blockchain. I mentioned before, many individuals will carry on using social media, but use a Web3 equivalent of social media. But I have seen some inklings, which is kind of a bit interesting to me, and that is some kind of hybrid. Tumblr, for example, has been doing some work to use both centralized and decentralized social media. So as a user, you'll have a choice to either keep your data in a Web3 under your control or use a centralized version. And that may be the way that social media starts to go, depending on public pressure, I guess. And that's it. That sort of wraps up my talk. Last few is references for your information. So I'd like to just open it up for final questions or comments or input, or tell me I'm smoking something or whatever.
Peter, if you would like to